let's have a look at question 3. Let's do part I first. So at time t seconds, where t is more than or equal to 0, a particle p moves so that its acceleration a meter per second squared is given by a equal to 1 minus 4ti plus 3 minus t squared j. So basically, because you have variables inside the acceleration, so it has to be variable acceleration. So if it's a variable acceleration, we should use differentiation or integration to solve the question. So it's not about SUVAT anymore, because it's a variable acceleration. In this case, at the instant when t equal to 0, the velocity of p is equal to 36i, and we want to find the velocity of p when t is equal to 4. So if you have acceleration and you want to figure out the velocity, we should use integration. So first we have a is equal to 1 minus 4t for the I component, and then 3 minus t squared for the j component. And if you want to find out velocity, we do the integration. So velocity is the integral of acceleration. So if you integrate it, you have to integrate for both components. So for the I component, so 1 will integrate to t, and then minus 40 will be minus 4t squared and over 2 plus 1 the power divided by the power. And then 3t minus t cubed over 3. And then don't forget, you need to put plus c here. And then again, c will also be 2 dimensions. So that would be I and j component for c. And then we can use the condition when t equal to 0, the velocity equal to 36i. So if t equal to 0, v is equal to 36i, then we will have 36,0 is equal to, so 0 minus anything times 0 is 0, so just 0, 0, and then plus c. So c is just equal to 36 and 0. So therefore our acceleration would be velocity is just equal to t minus 2t squared, and then 3t minus t cubed over 3 plus c, which is 36,0. And the final expression would be t minus 2t squared plus 36, and then 3t minus t cubed over 3. That's our velocity. And then we want to work out the velocity when t equal to 4. So we just let t equal to 4 and substitute in. Then velocity is equal to 4 minus 2 times by 4 squared plus 36. And then 3 times 4 minus 4 cubed over 3. So now if we put that in the calculator, we should have, so 4 minus 2 times by 4 squared plus 36. That will give us 8 for the I component. And then for the j component, 3 times 4 minus fraction 4 cubed over 3. That would be negative 28 over 3. So that would be the final answer for part A. And then let's have a look at part B. So it says, find the value of t at the instant when p is moving in a direction perpendicular to I. So as long as they're talking about the direction of the motion, then we should use velocity. And then is it moving in a direction which is perpendicular to I? So if it's perpendicular to I, that means it has to be parallel to j, because I looks like this. Now if it's perpendicular to I, it has to be this component. So it has to be in the same direction as j, so parallel to j. So first we can put our velocity vector here. So we have t minus 2t squared plus 36, and then 3t minus t cubed over 3. So we're looking for a value of t, which makes our velocity vector parallel to j, which is 0, 1. And then we know anything times by 0 has to be equal to 0. So like, for example, we know 0, 2 is parallel to 0, 1. Why? Because if you times by 2 for the j component, you get 2, and then 0 times by anything is equal to 0. So Doesn't matter what the scale factor is. 0 times anything is 0. So we know any vector which is parallel to 0, 1, the ji component has to be equal to 0. So for example, 0, 3 is parallel to 0, 1, 0, 4 is parallel to 0, 1. So it doesn't matter what that vector is, the I component has to be equal to 0 if it's parallel to 0, 1. So therefore, t minus 2t squared plus 36 has to be equal to 0. So then solve that. So t minus 2t squared plus 36 equal to 0. Rearrange it. So 2t squared minus t minus 36 equal to 0. So put that in the calculator. We will have, so 2 is A, negative 1 is B, negative 36 is C. So we have t is either 9/2 or negative 4. Clearly, time cannot be negative, so this is not valid. So t equal to 9/2. Now let's have a look at the second part, so II. At time t seconds where t is more than equal to 0, a particle q moves so that its position vector r meter relative to a fixed origin O is given by the following. So I equal to t squared minus ti and then plus 3tj. We want to find the value of t at the instant when the speed of q is 5 meters per second. So they gave us the position and they want us to work out the time when the speed is 5. So first we can differentiate because the velocity is the derivative of displacement. So dr over dt will give us the velocity. So, and then when r is equal to t squared minus t for the I component, and then 3t for the j component. So if we differentiate with respect to t, then v is just equal to, so t squared minus t will differentiate to 2t minus 1, and then 3t will just differentiate to 3. And then the speed is the magnitude of the velocity. So to work out the magnitude, we can just do square root of 2t minus 1 square plus 3 square, and that will give us 5. So square it for both sides. 2t minus 1 square plus 3 square is equal to 5 square. So make 2t minus 1 square as a subject. So 5 square is 25, minus 3 square, which is 9. So we have 16. And then 2t minus 1 equal to plus or minus 4. If we square root it, then 2t equal to 1 plus or minus 4. Then t equal to 1 plus or minus 4 over 2. So that means the first value is 1 plus 4, which is 5, and over 2. And the second value would be 1 minus 4, which is negative 3 over 2. And then again, t cannot be negative, so this is not valid. So this will be our only solution. So time is equal to 5/2.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.